Can everyone see my screen?
Yep.
All right, everyone, I'm going to begin. So good afternoon and welcome to today's Southeast Region A4LE webinar, Building Inspections, Indoor Air Quality and HVAC Systems. My name is Ciarochi and I'm currently the Southeast A4LE Region President and will serve as your commentator today. I'm also joined by several others who will be serving as panelists and introduced in a moment. Our goal with today's webinar originated a few weeks ago when we as a group realized that many of our members were reaching out for assistance in gathering best practices as we are all embarking on this new normal as it relates to student instruction models and how our facilities play a role with the CDC, local and state requirements. As our school divisions continue to respond to the COVID-19 pandemic, we know that every district is facing both challenges and opportunities when it comes to reopening. And as a result of this, we are pleased to share that today we have over 100 participants, not only from the Southeast region, but from other states outside of our region. Today's audience consists of K-12 instruction and facility planners, architects, and numerous consultants serving our K-12 schools. It's our intent today to provide you an overview and details of proposed system changes and the facts surrounding these changes, such as implementation costs, restrictions, lessons learned, and to hear from a team of professional engineers as they provide a top-down summary on the challenges, constraints, and current recommendations that are coming from national organizations such as the CDC, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, to name two. Our hope will be that this will create questions and that our panelists can share their expertise and thoughts as you think about the logistical challenges you're facing in the opening of your school buildings. So now I'd like to provide a brief introduction and overview of our panelists today. First, we have Julius Williams, who serves as an administrative coordinator of environmental services with Prince William County Schools. He has more than 25 years experience in environmental health, safety, and facilities management in the university higher education, K-12 government and commercial settings. We have James Curry, who serves as the senior mechanical engineer for CMTA. He has dedicated his talents for 20 years in the design of HVAC, plumbing, and fire protection systems for facilities, for critical facilities, research laboratories, universities, science and technology, K-12 education, the arts, municipal, convention centers, and corporate organizations. We also have Tony Hans, who serves as the National Director of Sustainable Projects for CMTA. He has been involved with over 4 million square foot of zero energy projects, many of those being educational projects. Zachary Snyder, who serves as the lead electrical engineer for CMTA. Zach has over 15 years of professional experience working on educational projects. Utilizing his MEP and lighting expertise, Zach ensures that electrical and energy efficient designs are seamlessly and optimally executed by coordinating closely with the owners and the design team to surpass the project's expectations and to ensure that sustainable design principles are incorporated. We also have Taylor Morris, who works with LS3P's K-12 teams across 8 offices, providing ongoing research to advance K-12 educational design. Taylor focuses on how K-12 environments can positively impact children and teachers alike. And on behalf of all of our panelists today, we would like to express our sincere gratitude for all the work that Taylor has put into providing you with the presentation that's being discussed today. And last, we have myself. I currently serve as an associate superintendent with Prince William County Schools in Virginia. I work with new construction, land acquisition, planning, pupil transportation, and school nutrition. In addition to being the Southeast Region's president, I've previously served as the president of the Virginia chapter. So before our presentation, I want to turn it over to our facilitator, Taylor, who will provide a brief overview on the Zoom platform so that you'll be able to maximize your experience today with its features. Taylor?
Everybody. First, let's make sure that you can see the presentation. Right now, you should see a soccer ball in the top left corner. Now you should see one in the bottom right corner. As Al mentioned, you'll be able to ask questions through the presentation. or as he will mention coming up next. You'll be able to ask questions throughout the presentation, and to do so, please place your cursor below the finger, and you can submit a question by selecting the Q&A button. Lastly, don't worry about looking for the mute or video button. As an attendee of this webinar, you are automatically muted and your video is automatically off.
So today's webinar will use the following format, and thank you, Taylor. Our panelists will provide an overview presentation, and while it's being presented, we encourage you to submit questions using that question and answer, that Q&A feature at the bottom of your screen. And at the end of the presentation, our goal is to have this for about up to 30 minutes. We will then cull through the posted questions and give the remaining 30 minutes of our 1-hour time slot to answer as many as possible. Our disclaimer is merely that we do not have all the answers and that we will do our best to keep our responses as global in nature, knowing that each state and our jurisdiction has specific requirements. So in starting today, we felt it was important just to kind of give an overview of the overarching elements that are considered when we're returning to school. First and foremost, in all realms that work in education, that it is our goal that we have to protect our staff, students, and faculty. And our goal is to reduce the exposure, to mitigate the exposure to COVID-19. In doing so, we're trying to find a balance on how do we best minimize those disruptions to the learning environment? How do we continue to provide, as facility folks, to maintain world-class customer service in our facilities operations? How do we continue to serve best instructional needs of all of our stakeholders, from students to teachers to staff to parents? And at the same time, it's really working to focus on the mental readiness for our staff in this new norm, knowing that we are all trailblazing and we're all doing this together. And every day we find that you can plan one thing one day, but with all of the information you have at hand, and the next day you find you receive new guidance and everything you've done changes. So being agile is a key element in today's new normal. So at this time, I want to start off with turning it over to Julius Williams, who's going to start off with discussing the environmental considerations as you prepare to reoccupy your buildings. Julius?
Oh, thank you so much. And I certainly want to extend a thank you to all of the participants throughout the Southeast region that decided to take their lunchtime to spend some time with us today. What I wanted to go over briefly is just an overview in lieu of federal, state, or local guidelines for school divisions that you should be considering at a minimum these best management practices when you're preparing your facilities for reoccupancy following this extended vacancy. I know here in Prince William County, the governor issued his order, I believe effective March 13th of this year. And as such, many of our buildings have been, have had low to no occupancy during this time. With that said, you know, as we know, our buildings still function. We still have custodial crews that are working in these facilities that are in or out. So make no mistake, you know, we didn't shut our buildings down. We just scaled them back slightly due to the lack of occupancy in those buildings. One of the first things that I wanted to talk about as you consider reopening and reoccupancy for your buildings is moisture intrusion and mold growth. A lot of our HVAC systems are designed to operate based on what we would call normal working conditions and occupancy and seasonal conditions as well. Many have been shut down or scaled back, which can result in mold growth in your buildings. Increased humidity in our facilities, and again, depending on the region you're in, you know, will lend itself to you discovering some unwanted surprises when you come back to your facilities. Secondly, inspecting your facilities for water leaks. Again, if you don't have staff in the buildings right now in Prince William County, we currently have our custodial crews that are going through our buildings and doing their summer cleaning. But in some cases, you know, you can have a fan coil unit that may have a clogged condensate line. And if you catch it in the moment, that's one thing. But if that can run over the course of a month or two or a few weeks, you're talking wide scale flooding in your buildings. So you definitely want to have boots on the ground and inspecting your facilities for water leaks. Also, your foundations of the buildings as well and other areas of the buildings where there's potential for water intrusion. assessing your, reviewing your chemical storage areas. Again, this is a very, very key component to reoccupancy. Typically in your science labs, custodial closets, you may have chemicals that have been stored for an extended amount of time. Prior to introducing those chemicals to a laboratory setting, you may want to evaluate those chemicals for expired shelf life, as well as making sure that all of the containers are intact and not leaking or compromised. Again, in this setting where we have scaled back our HVAC systems, you may have an increased humidity situation that may have had an impact on your chemicals. It should also be noted when you're looking at your chemicals, give yourself ample time to properly coordinate disposal of expired products or products that have compromised containers. In some cases, that could be a 30 to 90-day window, and you certainly don't want to be in a situation where you're stockpiling excess chemicals that you no longer have a use for. Next slide. Floor drains. Again, as you return to your buildings after this extended absence, you're gonna get all kinds of smells and things that you have not seen in the past. Your floor drains are very, very pertinent to the operation of the building, and sometimes those can emit some gases. So look at all of your floor drains, your water traps in your building. Your HVAC systems, assess your filter replacements. Look for mold, stagnant water, pests that may have made those systems their home during this extended period. This is a great time to really get in your buildings and activate your preventative maintenance programs on your systems. Changing, in some cases, maybe upgrading your filters to a higher MERV rating, increased efficiency. Cleaning coils and ducts and your condensate pans. And again, this is an opportune time to get in your buildings and take a look at these systems. Here in Prince William County, we actually have a preventative maintenance plan for our ducts, our ductwork and our coils and HVAC systems. We go through every so often and we do a full-fledged cleaning of those systems. And, you know, along with the indoor air quality implications that you have there, the sustainability implications are even greater with a greater energy efficiency. Inspect your kitchen, your food prep areas. Again, when you have an extended absences, you have a lot of bugs and vermin that like to make their homes in your facilities when they're left unoccupied. Take a look at your food prep areas. Evaluate your grease traps. Again, most locales should have a preventative strategy for cleaning their grease traps, but these are all things you have to consider. And again, you want to give yourself ample time prior to reoccupancy to go through and start taking a look at these areas. In many school divisions, your kitchens are the most important part of your operation. Here in Prince William County, we still have our kitchens that are fully operational, providing food for our community members and students. And finally, you want to be prepared, proactive, and professional. I call that the 3 Ps. Being prepared for the onslaught of potential calls that you're going to get for indoor air quality as people return to the buildings is something you and your staff need to be prepared for. You have to take into consideration that the psychosomatic symptoms are going to be there due to the heightened sensitivities that people may have as it relates to COVID-19. And so I always advise people, practice empathy when dealing with occupants, and especially in these sensitive situations. So I will reiterate the 3 Ps: be prepared, be proactive, and be professional. I'd like to turn this portion of the presentation over to Mr. Tony Hans from CMTA.
Yeah, thanks, Julius. You know, I think I wanted to start out by just saying that it's been often talked about that we're all in this together, but I think that A4LE is really turning those words into actions. We're truly all in this together, but learning from each other staying, Al mentioned staying agile, staying flexible in this time. We have to lean on each other and really look at what is the information that's out there? How do we take this information and how do we make this as safe as we can for our staff and our students as we're reopening schools? So I just want to thank A4LE for doing this. You're really bringing each other together and enhancing the educational experience, right? In these times, we have to lean on each other. And so with that, we'll move into, some more of the details. We want to help facilitate these questions, and we've centered this around 4 discussion points. We're talking for a second about politics without getting political. We're going to get into the details of dilution, get into some of the details of containment, and then wrap up a little bit, there at the end. I think, go ahead to the next slide. And as we touch on without getting political, just touching on the understanding that we do have to stay agile. Things are consistently changing. The only thing that's constant is change, but the direction and the information is always evolving. And so the thing that is consistent is we know that we have to focus on how do we open and how do we bring our students and our educators together, and then how do we do that in the most safe way. And so really I look at this, and I first start out with saying that the building's HVAC systems will not end this pandemic. I do think that we have to look at these systems and say, how can we open these facilities? How can we understand what's going in to each specific building and understand that each specific building is a unique situation? And then how do we make the best decisions for our staff and our students, given that building and that environment? So Zach, you want to jump in here on some of our recommendations?
Yeah, so like we said, HVAC isn't the end-all solution. It's just one part of the puzzle. So before we dive into the HVAC, I wanted to touch on a couple other items that as an MEP engineer we can focus on. And a lot of it is trying to eliminate high-touch surfaces or making them touchless. Restrooms is a great example of where there's huge opportunities to do this. Some of these are simple changes. Some of them are going to be a little more costly changes. So obviously automatic faucets, automatic flush valves, automatic soap dispensers. Some of those are easy, some are not. If you're using hand dryers, maybe switch to paper towels so you don't have the hand dryer blowing some of the germs into the air. Even door openers on the restrooms, if you can prop the door open, sometimes possibly even remove the door as long as you have privacy at the restrooms to eliminate one of those high touch surfaces. Also on the plumbing side of things, water fountains, drinking fountains, high touch area, maybe think about going to the automatic bottle filler stations on those instead. Then all the students carry their own bottles. You don't have anybody exchanging germs. And the next slide, Taylor, is just some additional items you can do. Automatic doors, your entryways as the students are coming in every morning. Again, have the doors propped open if you don't have automatic doors. Even the doors into the high traffic area stairwells, for example, if you have door holders on those to where students aren't touching that door, day in, day out, on and off. Lighting switching, instead of having every time somebody comes in the room, hit a light on in an office, in a classroom, wherever they might be, eliminate all the light switches and make everything occupancy versus vacancy sensors. Again, just anything you can do to eliminate those high touch areas. And now to jump back into the HVAC, I'll turn it back over to Tony about assessing your building's air quality.
Sorry, excuse me. The often mute error. So I think it's interesting as we get into dilution to start really looking at the history of our buildings. The majority of our educational spaces are not brand new, and they were not designed to today's code. So I think really looking at your square footage and looking at your individual buildings and taking a step back with an HVAC professional to do that is a very important step. And I want to talk briefly about the evolution of outside air requirements. I'm new to this industry. I'm in my 24th year, but I do remember that the small amount of outside air that was required in buildings years and years ago into the late 80s when we were starting in design in the late 90s. And so there was really a fundamental shift. Outside air was first required to be at 5 CFM per person. So we're looking at 5 CFM per student. That made a fundamental shift and evolved to around 15, not to around, it evolved to 15 CFM per student. And it changed where buildings had to be designed with 3 times as much outside air. And that was a large shift in the industry. Now, that code change then goes state by state to when a state invokes that code and makes it required. This happened in most states in the A4LE Southeast region. This happened in most states in the mid-90s. And so around the mid-90s, you'll start to see that 3 times as much outside air was required in buildings. Today's code requirement is based around ASHRAE 62.1, which really goes to a square foot calculation and then pulls into occupancy. But it often equates close to that 15 CFM per student, 15 CFM per occupant. And so when you look at building assessments, many owners and districts that we work with, some of their earlier buildings, they have now gone back and renovated those buildings and changed out HVAC equipment. And they did these as maintenance changeouts. When they did those changeouts, did they upgrade the HVAC unit and try to increase the amount of outside air? Did they upgrade it 3 times as much outside air? Typically not. But those maintenance changeouts, so where does your building sit in terms of how much outside air is being provided to the occupants in that is going to be dependent on when it was designed and then how that was added, and does it really meet today's recommendations on outside air requirements?
And to that point, one of the items here is a lot what Julius said. It's preventative maintenance. I think that's your best first option. So go into those buildings, because what we're going to go through here, some of them have a first cost impact, some of them have a long-term energy impact. So those may be 2 different funding sources for you, but just recognize that adding a filter, it's going to increase the load on your fans. All right. Doing some of the sequence changes or increasing your outside air is going to have an impact on how much it costs you to operate your building. So these are important items to keep in mind. Okay. But I think the cheapest solution is to go back to your buildings as they're starting up and take a look at, are your systems operating as they were originally intended? Do you have the outside air Tony's talking about? Do you have the ability to increase or decrease? What's really controlling that? So your maintenance group's going to have to look at your outside air dampers, going to have to look at your actuators, your sensors, and then really try and flex your machines a little bit. Try and get everything to make sure that it is moving left and moving right, and all your dampers are working. So that's probably your cheapest first solution here, okay? Other HVAC strategies that I'm going to touch on next is going to be your building flush out. Now, this is all about dilution, all right? So something is inside, people bring it inside. How do we get it back out? We dilute it, we purge it, we flush it out of the building. All right, demand controlled ventilation, that's an energy strategy. That's really high on the hat for ASHRAE in terms of how do we increase outside air. The increased outside air and ventilation to your main building equipment, you may or may not be able to do that. Okay, again, that's the age of your equipment. You're going to hear me say something probably a lot in here, and that's consult your HVAC professional, because we're trying to keep this high level. So we recognize that there are a lot of different systems out there. Your MERV rating, your filter efficiency, we'll touch on that, explain to you what MERV is. I like to help folks come up with a plan B. All right, let's be proactive. Isolation spaces, this is as much a mental thing as it is a reality, I think. And then how can we actually treat our air? Let's go beyond filters and let's look at some of the things that, some of these buzzwords that we're hearing, UVC, bipolar, things like that. I want you to understand I won't go into a lot of detail technically about what they are, but I do want you to know that they are reasonable items to consider if you have the funds available. They do work, and we'll throw some ideas at you in terms of what these costs can be. So there are a lot of different systems out there, guys. So you've got your typical air handling units, you've got your dedicated outside air, you've got your DDC, you've also got some that aren't DDC. Some are pneumatic controlled. Some of them don't have controls at all. So you're gonna have to become familiar with your building, and your maintenance crews just You're going to have to rely on them to walk through these things. ASHRAE recommends maintaining your increased ventilation, but you have to be able to do that to hold your humidity levels. So you can't, again, qualified HVAC professional, you can't go in and just turn a lever and increase your outside air. It's going to have a negative impact on your humidity if your building was not made to control that. Okay? And then the recommendations in your existing infrastructure need to be able to accommodate anything that you're going to do. Okay? So consider the cost of these sequences and the additional energy costs. We're going to keep repeating that as well. Go ahead, Taylor. So building flush, I think one of the things that seems to be really grabbing hold for us is turn your buildings on a couple hours early in a normal occupied mode. So people bring things in the space after they leave. All that particulate, germs, things of that nature are still in the space. Leave the building on for a few hours, let it flush out and be ready for the next day. And then before folks come into the building, after your cleaning crew's done that night, consider turning the building on in a normal operating mode that morning to give it a nice, another just kick in the pants, flush, be ready for folks to come in. Taylor? Dilution. What is dilution? So yes, we're talking about diluting the air that's in the space. What that means is that most systems are recirculating systems, meaning that they're drawing air back from each room and in some instances from the entire school. And so what you're trying to do to dilute that is bring in that fresh air that Tony mentioned. So fresh air is good for so many different things. It's going to keep the space clean. It's also good for just removing some of that bad particulate, some of that bad air, and then just purging it throughout the day. So 2 hours before, 2 hours after, I'm seeing that as a very common approach rather than running the buildings at 24/7. Increasing ventilation. So here, opening your chilled water valves, control dampers. You want to watch, again, you can make a change, but you're going to have to monitor it. If you don't have a DDC system and you make that change, keep an eye on it, either through direct measurement and hopefully not through work orders, okay? Go to the next one, Taylor. Demand control ventilation. ASHRAE recommends that this be turned off. What is that? So demand control ventilation is an energy strategy which quite literally varies the amount of outside air delivered to your building based upon the occupants. And how does it do that? Well, it does it through monitoring CO2. When we inhale fresh air. When we exhale the byproducts, and one of those is CO2. And so that's become a reliable means of determining how many people are in a space. So an option to increasing your ventilation is to lower your CO2 set point. So what you're doing there is you're trying to determine how many people are in a space by how much CO2 is in the space. So you would normally set it day one, let's say 1,200. But what we're saying is an option to that so that you don't have to deal with the cost of changing your sequence and changing your control methodology is to lower that set point. That by itself is going to increase the amount of air. Again, consult your HVAC professional and see if your system's capable of that.
James, I'm going to add in here. We had an owner that said, we're going to do exactly what ASHRAE is saying. We're going to eliminate demand control ventilation, and we're going to run our units, our outside air units 100% of the time. And looking at some of their specific buildings, the buildings were not capable of doing that. Mm-hmm. And they would have caused more problems in that buildings than what they could have done if they would have run those ways. So I think it's very important that we look at that and understand the limits of the building. Otherwise, you're bringing in a lot of hot, humid air throughout the space, and you're going to quickly go outside of a comfort zone and create some major problems through humidity. So good points.
Yep, good points. Good, Taylor. Filtration. Your main systems here are going to be your air handling units, your dedicated outside air units. I would add to that fan coil units, split systems, any type of unit indoors that's going to have a filter. So each one of those systems to take a look at. Now, we'll get into MERVs here next, but when you hear the word MERV, what does that mean? Well, that's the filter's efficiency at removing particulate based on a certain size. So the higher that number, the more efficient that particular filter is at very, very small particulate. And in some instances, like HEPA filters or MERV 15, 16, it can even roll down to the smallest germs, okay? Each system is going to have limitations on what it can and cannot accept, okay? Some of them only have room for a 2-inch filter. Some of them have room for a 4-inch. Some of them have room for what's called a bag filter. Okay, so each one of your units is going to have to be considerate of that. Be aware too that the higher the MERV on your filter, the higher the cost typically. Also, the higher the MERV on your filter, the more frequently you're going to have to change it. A lot of systems are set with MERV 6 and MERV 8, which is pretty common. All right, that makes a good filter for removing dust, but that's really all it does. As you start to move into the 13 and 14, Taylor, why don't you go ahead and click for me? As you move into the 13 or 14 type of MERV, that is going to require a larger rack. Some instances, if you don't have a larger rack and you put that in, it's going to negatively impact your system's ability to deliver air, and it's going to tax the motors. So this is where that motor starts running at a much higher amperage, and it really starts to work a lot harder. So it's going to impact your energy. But on some systems, it could negatively impact the airflow to the point where you may freeze coils, like split systems may get frost on them, things like that. Tony, anything you want to add there? Unmute.
James, if I could add, if we go back to
Certainly.
that slide.
Go back one, Taylor.
Yeah.
You know, for myself, who works within a school division, you know, we get inundated with lots of calls from people who've seen publications that talk about one of the, I'll call it a turnkey solution that's being promoted, is to raise the MERV rating of the filters within your system.
Right.
And that there is an idea that, and I guess it comes from people who live in their homes, that they can just go to Lowe's or Home Depot and pay more money, buy a higher grade that will collect a lot of the dust and particulates, and they can just put that into their own heat pump that they might have at their house. But what I'm hearing you say here is it's not as easy as just increasing the rating of the MERV, and that there are many other things that have to be taken into consideration. So what would be, I guess, just a quick takeaway, because I think this is a very important slide that you share. What is the takeaway for somebody who really doesn't have a lot of knowledge, but they're getting parents and folks asking about the raising of the MERV filters? What I'm hearing you say is it's easier said than done. What are things that they have to consider or take into consideration before they just start putting higher rated MERV filters into their HVAC systems?
Tony, go ahead.
Yeah. So, Al, we had a recent owner that went through this, and I'm gonna give an example that'll I hope answer that question. Often systems, I see a lot of educational systems designed with MERV 8 filters through those systems. And this owner was looking at changing out their MERV 8 filters to MERV 13. And so the HEPA filter will catch the viruses in most situations. I haven't seen an educational facility that was designed in a way that had HEPA filters in it. You don't have that. That's not an option. So the MERV 13, often the COVID-19 virus will catch to a water molecule and through humidity. And the MERV 13 filter has a higher chance of catching that molecule and therefore catching that virus and allowing it to stay in the filter where it then can die. And so moving to a MERV 13 filter is where you're seeing some of the recommendations. However, what happens with a MERV 13 changeout, you not only have the increased cost, and if your filter rack was sized in a way that you can switch typically to a 4-inch filter rack will accommodate the MERV 13 filter. If you can afford to change out your filters to a MERV 13, you not only have to look at that cost, but now the MERV 13 will also catch so much more particulates. You're going to start catching more dust and debris. And so if you previously changed out your filters, let's say every 3 months that unit in that school had a filter change out needed, you may have to change out the MERV 13 filter every 6 weeks. And so not only the cost of the filter, but also the increased rate at which they had to be changed out also had to be taken into account. And then that had to be budgeted across a very large district. So I think it can tax a system because of the high static pressure. It's not a large change in pressure going from a MERV 8 to a MERV 13. You do have to pay attention to that. it's typically the fact that the MERV 13 filter then catches so much more and taxes the system because of getting clogged. And so having to understand that and understand, okay, how is that system going to run in that with that system with the clogged filter, and how often am I going to change that and can I afford it?
And I'd stack onto that too, Tony, that if you're looking at central air handling equipment or dedicated outside air units, the motors and the fans on those they're just stockier. I mean, they're just bigger pieces of equipment. So going to a MERV 13 there, I agree with Tony, it's probably not going to be a lot of a hit. You're just going to have to watch what your static pressure is, or how dirty that filter is as it picks up dust and debris. Now, something like your fan coil units, which a lot of schools do have, they operate on what we refer to as a little squirrel cage fan. And those are low horsepower fans. They do their work by really turning really fast rather than, doing a lot of horsepower. So those fans are probably not going to be able to, they may not be able to take a 13. But I would say that, you're still okay starting with that 13, but just be leery of it, all right, as you go, and keep an eye on how dirty it becomes.
So let me ask you, is it fair to say that most systems in our schools are more than likely, the predominant ones are designed at a MERV 8, MERV 9 rating. They are not designed to go to a MERV 16 that possibly health institutions might be using. And those MERV 16s they can catch the COVID-19, but a MERV 13 might be one that many of our systems could with a mechanical engineer's consultation. But in reality, a MERV 13 is not catching COVID-19 particles. It's when COVID-19 attaches to larger particles that the MERV 13 filter can grab. If it's dust, if it's a molecule of water, moisture, that's what it's grabbing. So it's kind of indirectly grabbing it. But what you're saying is even if you go from an 8 to a 13, you're going to catch a lot more particulates and stuff, and that it will increase the frequency that you have to change, as well as I think I heard you say there is a cost difference between a MERV 8, MERV 9 filter and even a MERV 13. So frequency, cost, and the fact that you're still not catching the COVID-19 molecule, I'll call it, but you are catching it when it attaches to larger particulates that a MERV 13 can capture. Is that accurate to say for our viewers?
Yeah, I think it's fair to say, and also paying attention to the humidity in the school. And so the MERV 13 it's closer to a bell-shaped curve. The MERV 13 becomes more effective, and test results are showing a higher chance of catching the virus when the humidity is maintained in that middle 40 to 60 range, so that it can catch that virus when it is on a water molecule.
And that's another thing that's coming up now that ASHRAE is studying is the humidity level in your schools. We did not include that here as something to really focus on because humidifiers, adding humidity to schools is typically not an issue. It's usually the other way around. It's dehumidifying. But that's what we're trying to say too, is be careful, because that 60% limit, you can hit that pretty quick. And if you're adding additional pressure drop, or you're making the systems do more work, or you're adding more outside air, you're going to impact, and you're probably going to clear that 60%. So keep that in mind. Okay.
Thank you.
Well, this is something that's coming up a lot in a lot of our pardon me, I'm distracted by the chat that just popped up. I'm not used to that. Say doctor's offices and testing centers. So these facilities are creating these isolation spaces. They may be taking one room or two rooms, and while they're expecting people to be coming in with this, they want a place where they can go and it be safe and in somewhat isolation from other areas. There are fairly low cost options that you can do for this. So I always like to be proactive, have a plan B, or not if, but when, so that's something to consider if folks are, real concerned about it. Part of the politics is perception, right? So we'll do everything that we can within reason to make it as safe as possible. So this is something to consider. Go ahead, Taylor. Did you blow by? Oh, yeah. All right, so this is not the sales pitch. This is to prepare you for the sales pitch, okay? The objective here is, there are two systems that I think are fairly low maintenance and that are really the buzzwords right now, and that's UV lights, UVC, UVCG, germicidal lights, and then bipolar ionization. So Both are quite scientific. I will not go into an extensive description of what they are or how they do what they do. But I will say that UV lights are, they're quite popular for a lot of reasons. One is, killing viruses, but they're also there because they can help keep your cooling coils clean. So a lot of companies will look at adding these for the sake of keeping their systems cleaner, which means more efficient for longer. So when folks come and they, you have this UV light, that UV light has to be in contact with the virus for a certain period of time before it can do any helpful work to help destroy it. So that means that you're either going to have an extremely intense UV light, or you're going to have a lot of them. And so UV lights do have benefits for sure. There are pros and cons. Some systems have a lot of plastics inside. Those plastics cannot come into contact with UV light for extended periods of time. That means plastic drain traps, wiring, and every unit has that. Some insulations, things of that nature will degrade and crack over time. And most maintenance personnel will tell you they hate a leaky drain, okay? A lot of the new equipment do have plastic drains because I don't have to worry about rust. So keep it in mind. Also comes with UV light comes the cost of maintenance. So the lamps themselves degrade over time, like you would see in a school gym. The color of the lights change over time. That's just because it's aging, it's putting out less light. So your UV lamps are going to do the same thing. So they recommend that those be changed at least annually. So those lights become a maintenance item, and if they're not changed, they would fail, and essentially you'd lose that effectiveness in destroying the virus. The other is bipolar ionization. Bipolar ionization is a fairly popular item right now, and there have been some pretty extensive testing on it through different manufacturers, but directly, there didn't used to be any on the COVID virus proper because there was none available for testing. But in the last couple of months, that's changed. So this seems to be pretty popular, and in some instances, a low-hanging fruit for an add-on device. Because the maintenance is fairly small, it is not a UV light. It doesn't negatively impact any of the internals in your system. But again, you're gonna have to look at this on a case-by-case basis. I would say that, if someone comes in and discusses it with you, make sure that they're presenting you with some type of document that shows you the effectiveness of that device with really treating and destroying any virus or anything of that nature, okay? Don't take it at face value, because you do have to have a certain amount of output of all of that to do any real beneficial work. Tony, add to that?
Yeah, I was going to add a couple of things to it. Let's touch quickly on UVC light. So the UVC technology has been around for a long time, and you're operating down in the 200 to 280 nanometers. It's a mercury vapor light. They don't make UVC as an LED, right? So understand that you're turning on a light that's going to use a decent amount of wattage, 60 to 100, depending on length, 60 to 100 watts. Are typical lamps inside small package units. And so there is a consideration for having those lights on all the time. That is an energy impact. Often we're looking at what's the energy impact but it does do a good job at cleaning things that attach to the coils. And so there is a cost consideration. So we typically sit owners down in designing new buildings and say, okay, here's this light, there's the unit. It may go out typically in about 5 years. This unit's going to cost X amount of dollars to change out this lamp in those units, times how many of those do you have in that facility. You're adding a little bit of cleaning to that filter to be able to add that UVC light in there. I have a daughter with asthma. When I changed out an HVAC unit in my house 4 years ago, I paid $300 on the residential unit and I added a UVC light. I will add in that light is harmful to the eyes. So if you're a technician, you don't want to go staring at that light. It'll make you feel like you have sand in your eyes for 3 or 4 days. It can damage a little bit and start to cause some irritation. But UVC light does do a good job if it can have the virus in front of it for a prolonged period of time. most units, the air is passing by the unit, so that kill rate is relatively small. So you're talking lower percentages of kill rates on the COVID-19 viruses. And so there's a lot of increased testing going on right now specific to COVID-19 with UVC. The testing that was done previously was not for that, specifically for COVID-19, of course. So, and then just pay attention to those costs, pay attention to the cost on changing out those lights and how often you have to change them through all of your facilities. That can be an encumbrance for a school district.
All right, Taylor, if you hit the next slide, what we'd hope to kind of leave behind is there is a dramatic swing in direct treatment outside of the filtration. So here's an example of a project that we priced up strictly materials, mind you, okay? So this is just a material comparison. But these are 3 options that we priced up for a healthcare facility, basically medical office building, because they were looking to make changes. UVC lights, $3,600, and you see those, that's a picture of what it essentially would look like inside of the units themselves. Bipolar ionization was around $1,500. Okay, and then they have what's called an electrostatic ionizing filter, which does a lot of different things, but as you can tell, it has a much, much higher price tag to it. I would say that this is just the material cost. So if you're doing a retrofit or a new installation, the multiplier on that for the actual installed cost is going to be pretty different. So your UV lights, you can take that and a retrofit. When we estimated it, it was about a 3-time multiplier because it had to be set in a rooftop unit, which means we had to run some different things up through the roof with some electrical. We had to do some flashing, things like that. Bipolar, it was a 5-time multiplier because we had to pull some pretty good electricity to various areas along the ductwork to make sure that we treated the entire thing. The ionizing filter actually had the lowest install cost because it, in that particular instance, just replaced the normal filter in the unit. And it had a potential to last up to 3 to 4 years. ASHRAE had one of these types of filters installed in their headquarters, and it ran for about 4 years before they had to change it. So there's a lot of pluses and minuses to these things, but I think the idea here is to make you aware that there is a first cost, but there's also that maintenance and the energy costs with that, okay? Tony?
Yeah, on the bipolar ionization, the added piece I was going to touch on is stepping back a second on bipolar. Bipolar ionizes the air. And one of the benefits of bipolar is it allows us to catch very small particles. So we'll call those PM 2.5 and PM 10, particles that are very small and can potentially pass through the lungs. The lungs don't do a good enough job of filtering them out. And so,
can you step one back?
Yeah, and so the bipolar ionization starts to itemize those particles, and the very small particles then conglomerate. And when they do that, they get large enough that they're getting closer to the size of dust, and they start to fall out of the air. Gravity, the force of gravity on the particle is large enough that it can fall to the ground, where it can then be cleaned up. And so bipolar ionization became popular in the last, I would say, decade, but it really grew in the last 5 years as there were code changes that said, well, if we're cleaning the air, then ASHRAE gave an amendment to the outside air requirements that said if you use bipolar, you can reduce the amount of outside air. Now, personally, I take that and I compare it to the studies on CO2 that show that education increases with lower CO2 levels. So we've been proponents of added ventilation, and you may use bipolar ionization to clean the air, but I wouldn't use it to minimize the amount of outside air being brought in. So as we look at our newer facilities over the last 5 years, we've really drastically increased the amount of ventilation that we're adding into facilities and really over ventilating. And this has been consistent with the CDC and what ASHRAE have both said is we want to add additional outside air and dilute, and we really like additional sunlight. and bringing in more light into these spaces. And so it's amazing how that has stayed consistent with things that also increase educational learning in educational spaces. So we're always big proponents of added ventilation and added daylighting. And so I would fall back to those components when you look at these. And then the last piece is just celebrating the outdoors. So, you know, really looking at our outdoor community spaces. Obviously, a lot of new facilities are built with outdoor learning spaces, but we're seeing a lot of owners look at the opportunity to create makeshift outdoor learning spaces now. And how can we really start to shift more classes so that students are learning and creating good learning opportunities outdoors. Increasing Wi-Fi has always been a component of that, so that we can make sure that we're getting good connections to educational devices while we're in those areas. But it does fit with the outside air ideas. It fits with the social distancing ideas. And so we're big proponents of looking for those spaces in educational facilities.
Not always with the humidity in the South, but.
So with that, I think we really wanted to close on just summarizing that we're wanting to pay attention to not if, but how, and really relying on our local groups to communicate well, look at the individual situation on a case-by-case basis, trying to understand the cost implications of those things, and then therefore prioritize. You know, do I want to spend my money on cleaning first, on secondly, on making sure my facilities are open and safe for operation. All the things that Julius said as he walked through the key components to opening facilities. But then if you only have certain allotments of money, how do you carefully spend that money on cleaning, looking at your dilution and outdoor air requirements and what is specifically happening in that building. And then as you start to move into other ideas of filtration, then extra containment concepts that we've covered here.
All right, thank you, gentlemen. So we're going to turn over just to some general questions, and I've had a few that were emailed to me, and I see we have a few that are posted here. So we're going to try to get to these with the time that we have remaining. One person's asking, and I want to try to summarize this. They're asking about the recommendation to open windows in schools, and that a lot of schools have been designed not to open the windows. Is there any general comment you might give to someone about when to open windows, when not to open windows? I know that it can work against a lot of our systems that are designed. So I throw that out there to any of you just to kind of give a quick answer for.
Julius?
I'll jump in and throw in some opinion too, if you want.
Yeah.
I'm a big proponent.
But I'll defer to you. Go ahead.
Go ahead,
I'm a big proponent.
We have a delay. So from an
added.
environmental standpoint, I'm sorry.
No, you're good, Julius. Please go ahead.
I'm sorry. I think there's a delay. From an environmental standpoint, and depending on your HVAC system, I'm never an advocate of opening the windows, especially depending on the region you're in, where you have a significant amount of humidity on the outside, and you're more than likely to hit the dew point, if you have your internal system running in conjunction with bringing in outside air, which is probably one of the other downfalls to increasing your outside air in your HVAC system. So it's a balance of it, and I think it's really geographically dependent on where you are.
Yeah, I wanted to hear it from the facility side, because the engineers will probably repeat the same thing over and over, right, Tony?
Yep. Yeah, we love added ventilation, but we like it being brought properly through the outside air systems. Not only are you going to get dehumidification, but you're also going to get the filtering that we're talking about, and that's so crucial to indoor air quality.
So the question I'd like to add to that is, I know that there are still many school buildings out there that still have window units. I guess the Friedrich brand window unit. What recommendation would you give to them when many of those rooms have operational windows as well? Would you say the same? Use the window unit itself and not open windows, or not? I know that's a loaded question.
It is. Go ahead, Julius.
I again, when you think about that, it's an option, but I would certainly add some other mechanical means of filtering the air and dehumidifying the air. I have a home in Washington, D.C. that's 100 years old that we have a window unit. We use window units in, and they create a ton of condensation, because we're not dehumidifying the air.
I appreciate that. I mentioned in the beginning, there's two things that a lot of facility folks are seeing, recommendations, and that our parents are seeing. And one is the increasing of the MERV filters, and the other one's opening up windows. And I know that there's a lot of pros and cons with that. So I think anything that we can add just to, if anything, commiserate with all of our other folks who are having to respond to that, I think that's beneficial. With filtering, there was a question early in the game, and I know you saw this. With the increasing of MERV filters, we talked about, would a dirty filter be possibly able to catch the smaller particles in theory? Getting back to the fact that the MERV ratings may not catch COVID-19, but they may attach to the particulates. So if those filters are not being changed on a regular basis and they're dirty, if you want to call it, does that actually allow it to catch smaller particles?
It can, for sure, yeah. Essentially, it's becoming clogged. So it's catching things as it's clogging up and becoming dirty. But the idea behind the higher MERV is that they're initially designed to capture, not capture over time. So a MERV will actually do the same thing. A MERV 13 or 14 or 15 will actually increase its efficiency. But at the same time, it's also increasing the amount of work that your motor has to do, or decreasing the amount of air that's being delivered to the space. So there's certainly a diminishing return over time on that.
Yeah, it's always better to keep cleaner filters and to not overtax the system with a dirty filter, and then just size your filter size for catching the particles that you want to catch.
Right, day one.
And I just want to add one other thing to that. As facilities start looking at increasing the filter efficiency, as Tony touched on, making sure that those filters fit properly into the unit, because a centimeter of space between the bottom of the unit and the filter is essentially going to render that filter useless to, in terms of capturing particles. So I think as people get excited about increasing their filter efficiency, it is imperative that they make sure that those filters properly fit into the unit.
Julius, that's a really good point too. Even on your preventative maintenance, when you go back and you look at the systems that you're starting back up, put in the gaskets, put in the filler pieces, make that one of your top priorities. Make sure that whatever filter you do have, as much air as possible is going through it.
All right, we've got one additional question that was posted, and I know I think they're asking just for a very brief explanation about the electrostatic ionizing filters. What do they do versus the bipolar ionization? That's a very quick way to be able to capture the difference between the two.
You have, let's see.
You have 10 seconds.
So the idea, no. The idea behind the electrostatic is to charge the particles so they collect and they bunch together, like Tony was talking about. So the idea there is that that bipolar and electrostatic in some ways is the same, is that it's charging the particles so they collect and they help load up in the filter. So part of the reason that a filter may have and again, sorry, I'm trying to not fall in the weeds here, but there are some filter manufacturers that advertise a very low pressure drop across their filters. And they do that by charging the particles and actually making them larger as they collect around others, and then they strike the filters. So it's really doing the same thing as the bipolar ionizing, but it includes the filter media with it. So rather than falling out on the ground, it's done as the air is coming in. It charges and then gets trapped in the filter.
Well, I think you did a great job with that answer. I will tell you, as a K-12 owner, one of the things I always say is a great attribute of a good MEP engineer is one that can try to bring things down into layman's terms for our educators. And I think you did a good job there.
Thank you very much.
I know we're limited in time. I'm going to go with one final question. Person just saying, where do UV light filters come into play, if at all, as a technology? Just want to touch base on that again, just to kind of summarize what we covered.
Yeah, so I'll take that, and I think UVC lights are often added to HVAC equipment in the terminal unit itself or in the air handler itself, because it is harmful to the average eye. So they can't be within where someone can see that light. So putting that in the HVAC unit itself is where they're typically made. You will also see UVC GI units, and those are the lights that you typically see in some restaurants where they're high close to the ceiling and they shine up at the ceiling themselves. They're shielded from the occupants so that they're not visible. Now you do have to understand that they only really cover that area close to that light fixture. So you may want to look at airflow and how many lights you have in a space, have that designed by a professional that understands the UVGI light and how it spans out into the space. But yes, that's where those two types of UVC lights can be installed.
All right. Hey, for the sake of time, we're going to have to end our webinar today. And on behalf of everyone, the Southeast Region chapter and our panelists, we just want to thank you for participating today and engaging in this dialogue. This webinar is going to be made available and will be sent to all the people who have registered. I do want to tell you that we are going to have one final webinar next week. It's going to be titled Cleaning, Custodians, and Communications, and it's scheduled for July 16th, which is a Thursday, 12 o'clock, same time. But folks, last but not least, I do have to put a pitch out for A4LE, and I would like to encourage anyone who's not a member to please consider joining. A4LE is an international association. It exclusively promotes K-12 educational design. We have individual group memberships, and as a practitioner, I've been in education close to 30 years and in operations for the past 15. I cannot tell you how beneficial I have found the resources and the annual conferences, and how they have just been able to allow me to follow the educational design trends and best practices in trying to do what's best in providing safe, healthy environments for our kids. So with that being said, I want to thank everyone, and we hope to see you next week. Thank you again for your participation today.